Restroom break. 1 minute. Go, run. Another. So, hey, came off again. What was that?
It's a different leg.
I know.
That's why I say
I'm trying to get them a better spot. Better. Ah, there you go. I think that's better. I don't care if the head gets cut off. Hopefully I don't knock it down. 1 minute, restroom break. No, you don't want a break?
Good morning, pharmacy. Good morning. Happy Monday. Happy Easter.
Yeah. I hope you had a good Easter. I didn't realize there's a lot of places that are closed on Easter.
Oh, yeah, I was salty yesterday with the shirt.
Oh my gosh, yeah, my son wanted canes. After lunch, he said he wanted canes for dinner. It's closed. Went to Sam's Club to pick up some things. It's closed. And I said, oh, that's actually nice. I mean, not so nice for consumers, but that's nice that they observe that. Anyway, I've updated Blackboard again. You've seen it last Friday. I made sure that I don't leave the campus until I've checked this because I wanted to see, especially we have 3 freshmen, right? Okay. So I'm going to return this, give it to you for probably 2 minutes, 3 minutes to review, because some of you, despite my several warnings, to read the instruction. It's like, it's so cute. Okay, he already knows. I don't even have to look at him, right? But let me make you feel better. This particular test, quiz 2, is notorious. I told you. Okay, you have to read the instructions because you don't know whether you're going to be asked of single dose, single day, or total quantity. And I said that 2 times today on the test as well. And circle those words: 1 dose, per administration, per day. Okay, total quantity. Like what I said, most of the time our mistakes are not because we didn't understand the topic or the concept, but because we're so freaking stubborn. Stubborn to listen to somebody. Stubborn to listen to your teacher at this point, yeah? I was talking to my friends about this. How come our kids don't listen to us? But they listen to anybody else, their playmates, their gaming mates, how do you call that, right? Any minute, right? They say something, or YouTubers, right? They say something like, oh my God, that's so real, right? But if we tell our siblings or brothers or sisters or friends or us as authority as parents, like, seriously? And then they hear it from somebody. Oh Mom, do you know that this is, but I just tell you that. It has to come from somebody. My friends and I were talking because her husband was the same way. She's a doctor. She's telling him how to like lifestyle change, how to lose it, and all this stuff. Didn't believe her, but then got a consultant for wellness. And like, she said everything. This person that we're gonna pay is saying the same thing. It's like I said, well, that's just life, right? So most of the time we don't believe the words that are coming out of people who are really close to us, truly. But that's the truth. Okay, this is a good lesson to learn. Okay, So when given a prescription, make sure what you're being asked about. Okay. This is written already. It's not even verbal. Okay. Don't feel bad though, because one quiz wouldn't kill you. One bad quiz wouldn't kill you. Your mistakes are there for lessons. Right? Right? There's a third quiz. That's why I make it a point that there's 3 quizzes, right? So I'd like to say I'm very happy with our seniors because they truly are working on their expert level. And I noticed, remember that day when I did highlight the difference between dimensional analysis and ratio proportion? Yes. The students who were actually flip-flopping, don't flip-flop them anymore. It takes 10 minutes. It took me 10 minutes to what? To explain that. Okay, but there was a diagnosis that happened prior to that. You have to know that, right? If I wasn't paying attention to your test papers and how you solve problems, I wouldn't have figured that some of you have problems with ratio proportion and dimensional. Did you eat a lot of chocolates? Just a segue. Okay, review that 1 minute. And then put them back in the basket and we will start.
Yeah, no, that's right. Oh, that's right? Yeah.
Questions, comments, violent reactions on your quiz. No?
Wait, how much is the question? What is 3% of 3? 3%. Because there's only 30 questions on that. 100 points.
Like each one is like 3%.
Yeah.
How many questions did I get?
30. Yeah.
Okay. Questions, no questions, don't forget to turn them back in, though they're recorded. You're not supposed to have them. Okay? Topic for today is the most hated, most dreaded by many. I'd say even some pharmacists don't like this topic. They said you don't use it. It's not true. We use it all the time. Dilution, allegation. Okay? But we're going to start off with percentage. Okay? Why are we starting off with percentage? We're starting off with percentage because the basis or the foundation of allegation is percentage. Okay? The basis, yeah, and then you repeat that, or the foundation of allegation is, and I've been kind of hinting this to you guys. It is not true that we don't use allegation and dilution. Let me give you a fun fact. A good number of those PTCE takers are already pharmacy technicians. But a lot of them are in retail, right, Ms. Jaylee? And here is when they fail. This part, the dilution part, okay, the allegation part. Why? Because you don't do this in retail. Antibiotic, I'd say pediatric, but you just measure the amount of liquid and then you use the reconstitute. That's it. There's no actual dilution part, allegation part that happens in retail. This is why they struggle. Okay. And this is one of the reasons why they fail on top of the law part. I have to squeeze that in. Okay. And pharmacology is about 60% of the PTCE, just so you know, okay? Broken down into 40 something and 20 something, okay? But it all boils down to pharmacology. Why? The drug-to-drug interaction is pharmacology, the patient safety is pharmacology, all of those. So we don't want you to be parents, to be memorizing the top 200 drugs, brand, generic therapeutic class, without you knowing what they are for, without you knowing what they're not supposed to be given with, without you knowing what the drug-to-food interaction is, what the drug-to-drug interaction is, and other interactions that may happen with those drugs. And those are so many questions on the PTCE. Okay, that's why I said it's become a pharmacology heavy test more than anything. Okay, and because of patient safety, you'll think, oh, there's no category for pharmacy math or calculations. It falls under patient safety. It even falls under law, your rules. Okay, that's why I tell you that. Okay, it falls under patient safety, and it's tied to your pharmacology as well. So it's not necessarily said on the blueprint that it's pharmacy calculations, but these topics that you're studying here fall under a certain category in the blueprint of the PTCE or 4 major ones. Remember, Jaylene and Ellie reported that. Okay. One of the reasons why those retail techs who didn't go to school fail, because this is not, of course, it's not part of the training that they get. Okay. So where are they going to get this from? Either they look them up or check the textbook or find somebody. I am recording all of this for you so that you can go back, and I've updated everything. And remember, each group is different. I can go fast on certain groups because they get it fast, but there are certain groups where it's like a half and half. Okay, so I try to go slow. Okay, going back to the topic. Allegation and dilution, the basis will be percentage. Okay. At the beginning, I was talking about percentage, fractions, and decimals, right? And I keep telling you this. A whole number can be converted to fractions. Yes or no? Yes. Okay. Over 1, right? So if I say 30, if I want to convert that to fraction, I just do over 1. Yeah. So I want you to agree or disagree with me. Okay. A fraction can be converted to percentage. Yes. So how do you convert this 30 over 1 to percentage? Divided by 1 times 100. Correct. Can a fraction be converted to decimal? Yes. Okay. So those are all interchangeable, and I want you to remember that. Okay. Because I don't want you to get overwhelmed once you see numbers, and then the question is in ratio, which is another thing. 1 to 10,000. That's a ratio, right? Can you convert this to fraction? Another yes. 1 over 10,000. Hint, hint, wink, wink. PTCE final exam. Okay. So when you're given this, don't get paralyzed. Okay. Convert it to fraction. You're having a hard time with fraction. What do? Convert it to decimal. Okay. How do you convert this to decimal? Give me a number. 1 divided by 10,000 would be 0.001. Okay. So I have just proven, we have just proven, you can convert a whole number to decimal fraction to percentage. You have to remember that, because sometimes, or many times, students are having a hard time calculating because they're given a ratio. Don't get paralyzed. Convert this to either fractions, whichever one will help you solve the problem. Is that clear? Okay. So now let's talk about concentration. When you say concentration, it's also the same as strength, which is how strong the drug is. Okay. What is the strength of the drug? Strength and concentration is the same. Okay. So this may be expressed in milligrams, okay, or IU, like your vitamins are expressed in IU international units or units, or the most popular percentage. Here's what I'm saying, percentage is the basis or the foundation of dilution and alligation. So we're going to talk about percentage probably a good 20 to 30 minutes. Okay, percentage. By the way, who's seen the older videos on your Blackboard? Okay. How's it different now? Sasha, I know you've been watching.
Because I have, wow, it just seems like the way out there, like, so like it kind of slows down because like the newer ones, but the older ones I can keep up. Not in my life.
Right, okay, because this is tailor fitted to your group.
Yeah.
So it's half and half. We got 3 new students, and then the rest of you have been here a while. Okay, so I could go fast on certain topics, but this topic is new to everyone. That's why I'm slowing down, okay? Luckily, we've gained 1 day of sorts, okay, because Michigan gave us 30 minutes and a 15 minutes. Tomorrow you're gone, seniors. You know that, right? You're gone. I'm not gonna do a big lecture tomorrow because you're gone. Instead, probably we're gonna do more worksheets on this one, okay? But I want to give you the basics or the foundation. So let's go back. Strength, we're gonna talk about percentage as a measure of strength or concentration of a drug. Okay. But this is when it gets confusing, okay? Percentage can be in different, expressed in different ways. Okay. It can be percent weight over weight. Can you see? It can be percent volume over volume, and percent weight over volume. 3 ways percentage is expressed. Here's the problem though. On the test, you will not see the weight over weight, the volume over the volume, or the weight over volume, just percentage. So if you don't know the drug or the chemical or the reagent we're using, in what form they come in, you may be confused, okay? But there are keywords, okay? If you see it's an elixir, it's a suspension, it's a syrup, what do you think that form is? Liquid, right? So it's either gonna fall here or here. You follow? Okay. If you see that it's a lotion, cream, ointment, suppository, semi-solids, where do you think it will fall? On the weight over weight. Listen to those words, okay? Because this is invisible. Okay. Another thing I'd like you to remember, when we're talking about weight over weight, the unit will always be grams over grams. So if you see in the word problem milligrams and its percentage, the first thing you do is convert it to grams, because your percentage will be wrong if you don't. You follow? You know those things I'm telling you, I've learned by watching students do their math, okay? And I have to remember these things to remind you and give you this warnings, okay? Grams over grams. So this will be percent grams over grams, which can be expressed in another way, grams over 100 grams. Why? If it's percentage, it will be grams over grams times 100, right? You want to do another way to express it, it will be grams over 100 grams. Now you don't have to multiply it by 100. Are you following? Okay. But you have to remember this word. The numerator is your weight of solute. And the denominator will be weight of, we always say solution or compound, because it's easier to picture when it's solid to say compound, because solution denotes liquid right away. But we're on the weight over weight. Okay. Remember this, the numerator is solute, the denominator is solution, not solvent. Let me talk about these three words now. Solute, solvent, and solution. This is the best so far. I think I've broken this down. Solute, solvent, and solution. When God showered artistic, what's that? Capabilities. I was sleeping or hungover. Right? Remember my drawings? I don't want to draw them, okay? But this is a beaker. It's pretty easy to draw. Okay, so I don't want you looking at my drawings, but you remember my key, which is phenomenal. How I transitioned. Okay, so okay. Solute, solvent. Let's talk about this terminology. Solute, solvent, and solution. Okay. This is a beaker. And this is, let's talk about this as granules of sugar. And then I add water. What happens to the sugar? It dissolves, right? So it becomes one phase, right? One phase is called homogeneous. Now, the sugar is the substance to be dissolved. Hint, hint, wink, wink. All of this will come up on your final exam. Or maybe PTCE. The substance to be dissolved is what you call solute. Follow? The water is your solvent. Solute is the substance to be dissolved. Solvent is the dissolving medium. Can you follow? What happens when they combine? What do you call that now? Now that is called a solution. So this is sugar solution. Say, Master. Stir up, right? If we add heat on it. You following? Okay. Actually, you're going to think medical terms. This is actually your dextrose in water. Okay, but we'll get there little by little. Do you follow the terminologies? Miss L, but that's weight over volume. Now you're talking about. Yes, true. Okay, so we can equate this into two semi-solids mixed together, or a powder and a Vaseline. If you want to picture it that way, it could be either compounding or already. You mix a powder, active ingredient, with a semi-solid base, right? Or a Vaseline or a lotion, right? Then you mix it, then it becomes weight over weight, right? Okay. So since it's not liquid, you can call it a compound. And so which one now is the solute and the solvent in that particular example? The less one, the less amount would be your solute. The greater amount, or the base, would be your solvent to make the compound / solution. Can you follow? That's why I said always, always, always your weight measurement will be in grams. So weight of solute over weight of solution. Why did I talk about solvent when it's not in the equation? Why? Because some problems will ask you how much solvent was added, and you're going to reverse the problem. You're going to take out your total solution, your solute, from the total solution so you can get the solvent amount. Can you follow? We're going to get there as well. Okay? That's when it gets confusing, but know that this is your formula. Are you following? At this point, okay, no questions? Okay, so I want you to know the definition of solute, solvent, and solution. So for the volume, if grams is the unit that you should be using for weight, for volume, it should always be ml. Oops. Okay. This will be ml over ml. So if you had to calculate, okay, for the percentage, this will be ml of solute over ml of solution times 100. Can you follow? For this one, 2 solids are being mixed. Can you follow? Okay. 2 solids are being mixed. This one, 2 liquids are being mixed. Remember, semi-solid falls under here. Oh, okay. 2 liquids are being mixed. ml over ml. So it's going to be ml over ml times 100. Or, I'll put times 100 so you're not confused. ml over ml times 100, which can also be written as ml over 100 ml, so you don't have to multiply it by 100 anymore. Okay? This time it's going to be volume of solute over volume of solution times 100. I'll erase this now, okay? We're done here. You follow? The denominator will always be solution. Solution can be abbreviated as SOL or SOLN. Can you follow? Now 2 liquids are being mixed to make 1 solution. Okay? Next one. Weight over volume. What do you think this is? Since weight should always be in grams when we're talking percentage, this will be grams over ml times 100. What do you think is being mixed here? A solid that gets dissolved in a liquid to make a liquid, okay? Which are your IV bags. That's why a lot of the solutions that we're going to talk about falls under this. Follow? Okay. The first few days we're covering retail, a lot of retail, right? This time it's hospital. Hospital setting, infusion, okay? All of the ones that do sterile compounding. Okay. But not only sterile, there are non-sterile compounding that use this. Like what I said, ointments, suspensions not IV, okay, not injectable. Suppositories are non-sterile, compounded non-sterile, just so you know, okay? So we use this for compounding in general. Okay, how do we equate this now? Grams of solute over 100 ml, so you don't have to multiply by 100. And just follow the pattern. Weight of solute over volume of the solution times 100. This is set in stone. There's no going around this. So you know. Well, your word problems or the prescriptions that may be given to you are in milligrams. You know what to do right away if you're trying to get the percentage for the concentration. Okay? Or you're given in a liter, you know what to do right away. Okay? I'll pause 15 seconds and I want you to absorb this before I move on. Any questions at this point? No? We're still on concentration. Okay. I want you to know a couple of abbreviations though after this. Okay. Okay? Moving on. A couple of abbreviations that I want you to remember. Capital D stands for Dextrose. Those are the abbreviations that are commonly used in hospital IV bags, okay, or your what do you call this? Parenteral nutrition. Okay. Dextrose. Okay. What is W? Water. Okay. What is SWFI? Sterile water for injection. Okay. And then on chemistry, we covered a couple like what's Na? Sodium, which came from the word natrium. Excuse me. And then your Cl, which is chlorine or chloride. When combined with sodium, it becomes chloride. Okay. What's Mg? Magnesium. What's K? Potassium. Now we go NaCl. What's NaCl? Sodium chloride. Very good. Here's when it gets confusing, okay? Ns. What's Ns? Normal. Saline. Sodium chloride is a salt. Yes, no? Yes, that has sodium and chlorine. Right. Magnesium chloride is a salt. Yes, no? Yes. Magnesium with a chlorine. Okay. What's K? Potassium came from the word kalium. Okay. Potassium chloride is a salt. Yes, no? Yes. Potassium and a chlorine combination. Now we go to sodium chloride and NS. Okay. Because this is when problems happen. Okay. Some of you know this already. What's the equivalent of normal saline? 0.9% sodium chloride. I will leave this here for now. Okay, I'll get back to that. Okay, so you've learned these abbreviations that are commonly seen in your IV bag. I want you to picture and remember this. When you say dextrose in water, dextrose is actually sugar. So that's sugar in water. Remember my drawing a while ago, the beaker? Sugar dissolved in water. When you say normal saline or sodium chloride, that's salt. I'm going to say sodium chloride, that's salt. So salt dissolved in water. I want to focus on dextrose first because there's nothing extraordinary when it comes to calculation of dextrose. Okay. So when you say B5W, since we've learned abbreviations, you are to translate this, which you may have to on your final exam. This means dextrose, 5%. I want to see this, okay, in water. What does this mean? There's 5% of dextrose in water, in the solution. You've seen percentage, right? Right away. What have you learned just a few minutes ago about percentage? It can be weight over weight, weight over volume, or volume over volume. When I'm talking about dextrose 5% in water, what do you think that is? Weight over volume, because it's sugar dissolved in water. So this means this is 5% weight over volume. Can you follow? Which means if you're gonna let this number talk to you, or this number talk to you, this means that there's 5 grams of dextrose in 100 ml solution. Take note of how I set it up. Dextrose, solute. This one, solution. You follow? On one of your quizzes, or many of your quizzes, or practice tests, you'll be asked blank grams of solute. How many grams of solute? And your answer should be 5 grams of, which one is your solute? Dextrose. Solute is the substance to be dissolved. Can you follow? Yes? Okay. This is how you'd set that up. So are you picturing 5 grams of dextrose in a 100 ml bag? Okay. But it's not always 5 grams in a 100 ml bag. Sometimes your bag comes out to, what is this? 1 liter, 1,000 ml. So you think about ratio proportion, think about percentage. You think this has 5 grams still for it to be 5? Disregard my label. Let's talk about the size of the IV bag or the volume. This is 1,000 ml or 1 liter D5W. So if you said that 5% is 5 grams of dextrose for every 100 ml solution, is that still true here? There's 5 grams of dextrose here? No. So this is where the ratio and proportion comes into play. If you said that this is a D5W, how are you going to set it up? This is a liter. So it will be 5 grams over. Very good. 5 grams over 100 ml because you want it to be 5%. If this is D5W, but it's 1,000 ml, you want to know how much dextrose is in here for you to say that this is still D5W or 5%. What do you do on your proportion? Very good. X grams of dextrose or solute over 1,000 ml. Good job. Okay. When it's ratio proportion, what did I say? You have to cross multiply. Okay. So this will be 5,000 divided by 100. Your X will be grams of dextrose. What is it? 50 grams of dextrose. You want to check if that is correct? 50 divided by 1,000 times 100 should give you 5%. Now, is this 100 ml? Yes. This one has 5 grams of dextrose to make it a D5W, because this is a 100 ml bag. This one is 1,000 ml bag or 1 liter. Sometimes the problem will be written as 1 liter. You'll jump right away. What do? Convert first. Okay. So say this is a D5W in a 1 liter bag. Okay. For you to say that this is a D5W, there should be 50 grams of dextrose in here in a 1,000 ml solution. Is that clear? It's the best yet, I think, I've broken this down. Okay. So it's still a D5W. Percentage is correct. The strength is correct. The concentrations. You follow? Okay. Any questions at this point? Because it will be a little bit different from normal saline. That's why I said, let's put this on the side. Okay. Clear? Dextrose is your sugar solution. Now, breathe 30 seconds. We'll go to your normal saline, which is your salt solution. So picture now a salt in water instead. But here's what most test takers, most students have a mistake of doing. Sodium chloride is your salt. When you say concentrated, you say concentrated, or a chemical is concentrated. The solution is concentrated. When you say pure, that means that particular reagent concentration is 100%. The term sodium chloride and NS normal saline is most commonly mistaken or interchanged. I want you to know that this term normal saline means 0.9% sodium chloride. Not even 1%. This is why this is a very common medication error. Which case is that? It had this problem. Remember, a decision here in Summerlin Hospital is a case of zinc. Milligrams versus micrograms. Who's the other baby? Yes, what's the name? There was a law named after her. Emily. Emily's law. Emily Jerry, right? This problem. The tech compounded normal saline because they were out. So don't tell me you don't use this now. Okay, but you have to use it, right? Okay. Sodium chloride and normal saline, I can't be repetitive enough, is not the same. Normal saline has sodium chloride in it, but take a look. Not even 1%. Can you follow? Normal saline will always be 0.9% sodium chloride. Always. Always. So sometimes you get faced with a question either on the PTCE or final answer quiz, wherein you're thinking, oh, there's a number that's missing. I can't solve this problem, right? Because this can be invisible. Because it has to be known by you. Normal saline, no matter what, is 0.9% sodium chloride. Can you follow? Okay. You guys know that I'm an old school pharmacist, right? So I was part of the time wherein we had to make IV bottles. We didn't have bags. I mean, we do, but they're expensive, so there's just very little we purchased in the past. It came, we had this IV bottles initially, okay, that we purchased. And you hang that, I mean, the nurses hang that upside down, okay? You can either have normal saline or dextrose, okay? After that, we send that for sterilization and we reuse those bottles. When I used to work in the hospital swing shift, first thing I had to do. Okay, the bottles are ready right there in carts. Straight to the back. I have to weigh, do this calculation. I have to weigh salt, depending on the bottle and on the prescription. Pour that salt in the bottle. Okay, add the water, seal it, set it back in the cart. Somebody will pick it up and send it for autoclaving. Then the next day it comes back sterilized already. That's why it's easy for me to picture this. Now it's very easy. It's all in IV bags now, right? Ready for you to use. Okay, but I don't want you to forget because sometimes you will have to make them. Okay, and this is when this particular topic is important, and you have to know that normal saline will always be 0.9% sodium chloride. Another story, I had a student who worked at the Clark County Detention Center. And there was a nurse who said, why are you giving me half normal saline? I mean, why are you giving me 0.45% sodium chloride when the order is half normal saline? And she had to explain that a normal saline is 0.9% sodium chloride, so a half normal saline is going to be 0.45% sodium chloride. Can you follow? Okay, so let's talk about that. Percentage, this is in percentage. What does this mean? This will be 0.9 grams of sodium chloride, not normal saline, over 100 ml of the solution or the salt solution. Can you follow? Okay. So if I say, go back to this. This is a normal saline. What's the size of this bag? 1,000 ml or 1 liter. How much sodium chloride is in here? It's going to be 1,000 here. Are you following? Yes? I'll take this out. And this will be X grams of sodium chloride. What's next? Cross multiply. 0.9 times 1,000 divided by 100 should give you 9 grams of what? Don't say NS. I will mark you wrong. NaCl. Just the salt part. And take note, it has to be capital N, lowercase a, capital C, lowercase l. Can you follow? 9 grams of the solute. That's why this is a very, very delicate, most commonly mistaken, interchanged. So I'm telling you, normal saline, no matter what, will always be 0.9% sodium chloride. Is there sodium chloride in normal saline? Yes. Is normal saline same as sodium chloride? No. Okay. So if you want to check 9 grams divided by 1,000 ml times 100, you should get 0.9% sodium chloride. So my job before, if I'm to fill a bottle that's 1,000 ml, I would have to weigh 9 grams of the salt pour it in the bottle, and fill it up to 1,000 ml level. Can you follow? I said fill it up to 1,000 ml level, not add 1,000 ml water. Take note. We're gonna get there. Okay. Any questions? Because I want us to do 5-question practice on what I just talked about. Normal saline, sodium chloride, dextrose, okay? For you to be picturing it, visualizing it, easier for it to be easier. Think about dextrose as sugar, sodium chloride as salt, okay? You're making a salt solution or a sugar solution, okay? What do you call a salt solution? Brine. Remember? How come I'm short? I mean, I'm short in height, but how come I am short of seconds? Okay, can I borrow one? Don't you have it? Why am I short of seconds? Hang on, I keep it. How many? 4. What do you mean? 2? I'm short. Only 5 questions, okay? See how I planned it? Because I know we're going to slow down at this point. There's only 5 practice questions, so we can go over all of them. And then I'm going to give you practice problems for you to take home, and that's where we're going to start off tomorrow. So seniors, you're not really missing anything tomorrow, though you're going on your externship meeting. I will be giving the packets now, so you can work on it. And then I'll probably give the answers to the sophomores, the juniors, and the freshmen tomorrow. Just compare it, okay? Or you can come to me and ask for the answers for that. But this 5-question one, we're gonna go over. We've got 10 minutes, 8 minutes, so we still have time. Ratios of IV bags. Wednesday, we start allegation and dilution. You see how it is? Okay, so I wanted to make sure that you're not missing out on anything. Ratios of IV bags is going to be your homework. It's not due 2 days from today, though. This is due tomorrow. Take note. This ratios of IV bag is due tomorrow. Do not turn it in the basket. Okay, do not turn it in the basket because we're going to go over the answers tomorrow. So seniors, it is your responsibility to either check in with me for the answers for that or the ones who will be left here in the classroom. Okay, so that you know you did it right. Ratios of IV bags. You know, this math is not only for pharmacy technicians, not only for pharmacists, not only for pharmacy technicians. Who do you think would have a good use of this particular math? Nurses. Yeah, vet nurses. Okay. Ready? Do we have answers to just 5 questions? I made it a point that's short. Yeah, because I know we're gonna run out of time today. Ready? Are you ready? Are you ready? Yes, no? Again, that homework that I passed, 15 questions, ratios of IV bags, is due tomorrow. have a very thick practice problem before finals. One more quiz that involves allegation and dilution. Finals is when? Tuesday next week. Yeah. And then seniors are out of here. Not that I'm happy. I mean, it's always a mixed emotion. Very bitter. All the time. How many heartaches do you think I had? Because we've gotten used to each other, but also we're happy because you're finally in each other.
Am I right?
Okay. Let's do this. Practice problem. Answer. How many, first one, how many grams? Listen up. How many grams of NaCl are in a 250 ml bag of normal saline? So this time your bag is 250, but it's normal saline. Jessica, answer. 2.25 grams of, it has to be NaCl. Okay. Before I move on, I don't want to forget. I just assume, never assume, right? So if you have NS, you said normal saline is 0.9% sodium chloride. Half NS would be what? 0.45% sodium chloride. A quarter NS would be 0.225% NaCl. You follow? Okay. How did that happen, Miss L? You just divide by 2. This one, that's your half. You divide this by 4, and that's your quarter. Okay. Next one. Number 1, who got 2.25 grams of NaCl? Hands up. Where are my freshies? Okay. Ellie, you're raising your hand. Did she get it? JD? Yeah. Okay. Number 2, JD. How many grams of NaCl are in a 250 ml bag of half normal saline this time? 1.125 grams of sodium chloride. I can't be repetitive enough. NaCl. Okay. Who got that one? So your ration proportion will be based off of this. 0.45 grams over 100 ml equals X grams over 250 ml. Can you follow? Okay, very good. Number 3, Emmy. How many grams of NaCl are in a 250 ml bag of quarter normal saline? We got 0.5625. Okay, 0.5625. Is that correct? Let's double check. It's quarter normal saline, so we have to do quarter normal saline would be 0. To not forget the leading 0, drop the trailing 0. Okay, 0.225 grams over 100 ml equals X grams over 250 ml. Can you do the math? 0.225 times 250 divided by 100 would be 0.5625 grams. Okay, 0.5625 grams of what? I do not want to see NS. NaCl. Capital N, lowercase a, capital C, lowercase l. You follow? Okay. You might ask me this out. It's too long. Can we just chop it to 0.56? Yes, 2 decimal places. But follow the instructions on the test. Okay. If the test says less than 1, keep 1 decimal place, then this will be 0.6. Okay. If it says keep the hundreds place, then it will be 0.56. Stick to the instruction on the test. Always. Yeah. Okay. I guess we learned our lesson. Number 4, Ashley. How many grams of dextrose are in a 250 ml bag of B5W? Are you confused on this one? This one is dextrose, nothing extraordinary, right? So you find that number between the D and the W, which is 5 grams or 5%. So this will be 5 grams over 100 ml equals, how big is your bag? 250 ml. So this is your X grams. And this will be what? 5 times 250 divided by 100. Your X will be let's wait for Ash. Edwin, you're number 5. You got all this women helping you, Edwin. How does that feel? Oh my God.
Yeah.
Just like Omar, right? It's probably too much sometimes.
No, he's a sweetheart.
I mean, it's probably too much for him sometimes. Like, can you imagine 10, 11, 12 women? Okay, Ashley, number 4.
12.5 grams of dextrose.
12.5 grams of dextrose. Who got this one? 12.5 grams of dextrose. Number 5, Edwin.
25 grams of dextrose.
Number 5, how many grams of dextrose are in a 250 ml bag of B10W? So it's 10%. 10 grams over 100 ml equals X grams over 250 ml. What's the answer?
25 grams of dextrose.
25 grams of, it has to be dextrose as your solute. Okay? Do not do 25.0. Drop that trailing 0. Remember the rule. PTCE follows this. Drop that trailing 0. Do not forget to leave the 0. Real quick, we're gonna have a quick promotion. Why do you like Pima, Maddie? Why? Oh, you like your teachers a lot. Okay, Ashley, why do you like Pima? Are you staying here?
Yeah, I'm saying
It's hard.
I did like
This is ambush.
yeah, I do like it have a smaller class and actually learning.
Smaller class and you're actually learning. Okay, what about you, Geneva? Why do you like Pima?
It's very small program, but like a lot of things to learn.
Very small what do you mean, short?
Yeah, short program.
Short.
But a lot to learn.
A lot to learn. Okay, so you like the challenge?
Yes.
Okay, Edwin,
It's fast paced.
very fast paced. You like it fast paced? Oh, you like it fast paced. Good. Okay, other stuff. Kristen, why do you like Pima? Why are you here?
I mean, to study more about great teachers, great staff, and hang out with people, make friends.
Make friends. So true, yeah. Your class is so tight. Jessica, why do you like Pima? Yes, this is a promotion.
I like it because it's very family friendly and it's like something like you can do with your life. And it gets you there very quickly. And it's very informational in general as well.
Very family friendly. Get you there quickly. And what was the last one?
Informational, like you learn a lot.
We learn a lot.
Short period.
In a short period of time. I agree. Okay, what about you, Janae?
I like learning all of the information very fast and how I can as well as all the friends.
Aw, okay. Jane? You like the environment. That's important, okay? The learning environment is very, very important to you. You guys like this. Okay, what about you, Ellie? I can't hear. Your bags, I'm deaf. What did you say? Oh, hands-on experience, great program accredited by 2 organizations, accrediting body, that's APHES and ASHP, if you don't know. Okay. Oh, great teachers. Yeah, you guys said that. Thank you. Thank you, Miss Jaylene. I wish Miss Jaylene was here, but she's preparing again for another class. So thank you, thank you, thank you. What about you, Stasha?
Because you guys are like the most knowledgeable teachers that like teaching.
Yeah.
Oh yeah, because we know that we're getting the education that we're supposed to get, and because you're super thorough.
Oh, okay, yeah. We won't put a vet instructor here in the pharmacy program. Okay, thank you Okay, guys, I'll see you tomorrow. Seniors, do not forget your meeting tomorrow. Homework is due tomorrow, not